Hello and welcome back. This is part 4 of annotations of E3D 4.0 course on creating intelligent drawings. By now you should be able to create the views on a sheet of the 3D model and label the components, as well as create linear dimensions along the view X, Y direction or along the components. If you think you need a revision, you can view the session you missed by following our playlist. In this lesson, we'll cover the 3 angular dimension types in E3D: angular, pitch circle, and radial. The angular dimension is as shown here. It measures the angle between two reference lines, for example, between nozzle center lines on a vessel. In this view, the dimension shows how each nozzle is positioned around the equipment, such as 30 degrees, 60 degrees, or 90 degrees. You can place the dimension inside or outside the angle for better clarity, and it follows the project's dimension style for consistency. Next, we look at the pitch circle dimension. This dimension is used to show 2 points on circular feature, like the diameter and radius of the column. Finally, we have the radial dimension. This dimension takes its value from the attribute of the 3D element that is linked with the dimension. You can use it for cylinder, vertices, radius used in extrusion and other circular features. Now we'll see how to create each of the angular dimensions we just discussed. Now, let's start the lesson proper. We'll begin by creating a drawing for the column C1101, which will be suitable for demonstrating angular dimensions. If you're not yet familiar with how to create a sheet and place a view, this would be a good time to go back and review that process. It's an essential foundation. I will use the 3D view to help us to define the view. Let's adjust the scale. You can use zoom, like in 3D view, to get the scale that you want and choose a reasonable scale from the drop-down as well. Let's select apply to confirm the view that we need. Next, we'll set the representation to global hidden line to ensure the view displays only visible edges. This gives a cleaner and more technical appearance. We'll also adjust the view limits to remove the excess blank space, so that the drawing is properly centered and visually balanced. Now we're ready to start creating the angular dimension. We'll now select the angular dimension command, and choose the chain type. The chained option allows multiple angles to be measured consecutively from a common reference line, useful when you need to show the spacing of several features arranged around a circle, such as nozzles on a vessel. Next, we'll select the dimension points by picking the P-points of the nozzles. After selecting the first nozzle, we place the angular dimension at a suitable location on the drawing. We then continue selecting the remaining nozzles. Because the dimension points are associative, any change in the nozzle's position around the center will automatically update the angular dimension. Next, we'll use the grip handle on the existing angular dimension to add additional angles. This allows us to quickly extend the chain dimension. Let's look at some of the properties of the angular dimension, ADIM, that control its appearance. We'll make these adjustments using the Properties panel. If the panel is not currently visible, you can open it by selecting Properties Grid under the Display tab in the Home ribbon. Next, we'll go into the Vertices section to make changes to individual dimension points. We are going to place the nozzle tag directly on the dimension line. This keeps the drawing clean and clearly associates each angle with its corresponding nozzle. We look for the property that controls the text behavior of the dimension point. By default, this setting inherits its value from the dimension owner. I'll change it to No, so that this point can have its own independent text properties. With that done, we can now define the project text for this specific dimension point, using intelligent text to display the nozzle tag automatically. Since we want all the dimension points within this dimension to display the nozzle tag, we'll set the dimension point inheritance back to yes. We now go to the dimension element itself. By default, the dimension inherits its projection setting from the dimension style. To customize it, we'll change this option to no, allowing us to define our own settings. With that done, we can add intelligent text for the dimension projection text. All the dimension points are now updated with the new settings. In our current setup, the nozzle name includes both the equipment name and the nozzle tag. If we only want to display the tag, we can modify the intelligent text expression to extract just that portion. To display only the tag portion of the nozzle name, we'll modify the intelligent text with a text manipulator, (P2). This tells E3D to extract just part 2 of the nozzle name, the actual tag, and omit the equipment prefix. We can see that a slash appears in front of the tag. To correct this, we'll use the C2 formatting option in the intelligent text expression. This tells the system to start displaying from column 2, effectively removing the unwanted slash and showing only the clean tag text. Let's move on to the pitch circle dimension, or PCD. To begin, I have copied the existing view from our previous example. This new view will be used specifically for our pitch circle dimension, PCD. When you right-click, the navigation wheel appears. From this wheel, select the footstep icon. This command lets you navigate directly to the chosen view. We access the PCD pull-down menu, which lists several options for creating pitch circle dimensions. Each option provides a different arrangement, such as circular spacing, angular layout, or radius-based configuration. We select one of the options from the PCD menu. To define the pitch circle dimension, we pick 2 points, the center of the pitch circle and a point on the circumference of the arc. The dimension appears according to the selected option. If the setting is for diameter, the value is twice the measured radius. If it is for radius, the value shown is the measured distance. Use the plus grip to change the angle, which controls where the dimension is displayed around the circle. We now look at the other PCD options available in the pull-down menu. We select another option, where the dimension is placed inside the circle. We select the radius option to see how the pitch circle dimension is displayed in this format. The dimension now displays the R symbol, indicating that the value represents the radius instead of the diameter. We create another pitch circle dimension using the radius option, then proceed to review the properties of the PCD. We open the Properties pane to inspect the settings. The element type for a pitch circle dimension is PDIM. We change the visual style of the dimension. The list of properties can be quite long, so we set the display order to alphabetical instead of grouping by function. Since the list is in alphabetical order, the visual property appears near the end of the properties list. We change the visual style from the list, and the dimension updates immediately to reflect the new appearance. We want to change from diameter to radius mode for the dimension. To help us find the setting, we switch the property view back to grouped mode. We collapse the property groups to make the list easier to read and focus on the key settings. We find the settings in the miscellaneous group. Here, we change the dimension mode from diameter to radius. The dimension updates immediately, reflecting the new settings. We set the mode back to diameter, and we're now ready to move on to the final type of angular dimension, the radial dimension. Let's start radial dimensions by moving to another view. We open the radial dimension pull-down menu, which lists several creation options. Similar to the pitch circle dimension, the list is divided into diameter and radius types, each offering different visual styles. We select one of the diameter options from the radial dimension menu. Unlike the pitch circle dimension, this command requires selecting a 3D element, and the value is derived from the element's properties. Not all elements are suitable. For example, a box cannot be selected, but a vertex of an extrusion element with a defined radius can be used. We create another radial dimension using the radius mode to display the radius value instead of the diameter. Let's inspect the properties of the radial dimensions. Let's find the visual style. This time I will find it within the grouping order. We collapse the property grouping and locate the visual style setting under the representation group. The dimension is updated as we modify the visual style. We select another radial dimension in the view. This particular dimension references a cone element. Let's modify the property attribute key. Because this is a cone element, you have three choices: diameter, d-top, and d-bottom. When we set the property to d-top, the dimension updates to show the top of the cone, representing the smaller diameter. We create a projection view to demonstrate how the radial dimension can be applied within this type of view. With the projection view ready, we proceed to create the radial dimension in this view. Looks like I have selected pitch circle dimension. Let's delete and do it again. This time, we ensure that the correct menu option for the radial dimension is selected before placing it in the view. By default, the radial dimension is placed at an angle. We change the angle value to 0, and the radius is now dimensioned correctly in the projection view. When we modify the attribute key property, the dimension location updates automatically to reflect the new setting. In this lesson, we explored the three types of angular dimensions in E3D: angular, pitch circle, and radial. We learned how to create, modify, and control their appearance through properties and intelligent text. Each type serves a different purpose, from showing angles between lines, to circular spacing, and radius or diameter values. If you found this lesson helpful, we'd really appreciate it if you liked the video and subscribe to our channel for more E3D training content.